Okay, so this is a question. This is the very first question we're solving today. 2016 Winter 4-2, Paper 4, Variant 2, question number 2. This question is based on kinematics, so be expecting any question from any direction. You know, kinematics has got three branches: the graph, the calculus, and the SUVAT equations. So the 10 questions you'll be solving today cut across all the three branches. So it's not going to be like inclined towards one particular aspect. So just be prepared for any question. This question was all the questions are actually from either 2016 or 2018. I don't know why I chose those years, but I don't know. I just chose 2018 and 2016, and they are all winter questions. So maybe because I'm an African, I like winter. Yes, it's not something normal to us. So okay, a particle moves in a straight line. Is displacement t after leaving a fixed point O on the line is s meters, where s is equal to 2t squared minus 80 over 3 t raised to the power 3 out of 2. Find the time at which the acceleration of the particle is 0. Wow. And find the displacement and the velocity of the particle at this instant. I don't think this should be difficult for you. Any ideas as to how to solve this?
So I just integrate it twice and equate it to
Okay, so Diva
0.
is going to work over here. Nice. Okay, so Diva. So you differentiate displacement function, you get velocity. You differentiate velocity function, you get acceleration. So you got it wrong, you know. You said you are going to integrate it twice. You're going to differentiate it twice, not integrate it twice.
I said integrate. Oh, sorry.
The displacement function was given, so you have to differentiate it twice. So let's do the first one, since you already know what to do about this. Or let me just leave you to see what you can give me after doing your differentiation.
Okay, I got T as 25.
Get T as 25.
Yes.
Okay. Okay. So let's solve for T together and let's see if you are correct. Is that okay? Okay. So like I said, Diva, you differentiate a displacement function, you get a velocity function. You differentiate the velocity function, you get acceleration. So the displacement function was given as 2t squared minus 80 over 3 t raised to the power 3 over 2. V will be equal to the derivative of this. If you differentiate 2t squared, what will you get?
40.
40. That is very good. Minus this should be 40 and t raised to the power 1 over 2. I don't know if it's correct. Cross check. Is it correct?
Yes.
Okay, that's correct. That is very good.
Yes.
Now, we're going to differentiate this function again to get as that. This should be 4 minus 20 over root t. Or it's the same as 4 minus 20 negative 1 over 2. Did you get something like this?
Yes, that's what I got.
Okay, so we have to find that the time at which the acceleration is 0. So it means that this should be equated to 0. Acceleration is 0. So 0 is equal to 4 minus 20 over root t. I can multiply both sides by root t. This gives me 0. 4 root t minus 20. The 20 goes to the other side. 20 is equal to 4 root t. And 5 is equal to t. And t becomes 25. Okay, so that answers that part of the question. Is that okay?
Yes.
Okay, so the next question says we should find, my line is crooked. We should find the displacement at this point, the displacement and velocity at this point. So what do you think we're going to do for this?
So you just put your t inside the displacement function.
Okay, so the displacement function s equal to 2t squared minus 80 over 3 t through raised to the power, sorry, t raised to the power 3 over 2. I substitute 25 over there. So s is going to be equal to 2 multiplied by 25 squared. That is 25. It doesn't look like 25. 25 squared minus 80 divided by 3 of square root of 25 whole cube. Am I allowed to write it this way? From
Yes.
in this, yeah.
Yes.
So after doing the manipulation, what did you get for?
You get negative 2000 eight no two negative 2083.3.
Okay, 0.3. That is very good. So what does this tell you? It's a follow-up question. It's not really related to the question. Displacement to be negative. What does it tell you?
This means the particle moved like backwards from its original width. That means the particle like passed its origin and went further.
Okay, so it has moved backwards, right? So if this is forward movement, this is where the particle started from, and this forward movement is positive. It means that the particle is at this side. So let's say start position, this start, and this is going to be end. Sorry, this is the direction of motion, positive this way, and a negative tells us that this is where the particle is at. So it's 2083.3 meters behind a starting position. Now, without even calculating, we are told to find velocity. What do you think the answer for velocity is going to be? Instant. What is instant telling you? Is it going to, not the exact figure, is it going to be positive or negative?
Negative.
Why negative?
Because your velocity will now be moving in the opposite direction.
So the velocity will move in the opposite direction as well. Okay. So that is very good. But it doesn't necessarily mean that it could be that at that point the particle started moving forward again. But that is what I actually wanted to hear from you. That's very good. So let's get a velocity function and do the same thing we did for the displacement function. Where's the velocity function? Okay, so let me continue from this. Since the velocity function is here. So let me continue this. Yeah. So with the velocity function, we got v to be equal to 4t minus 4t with t. When t is equal to 25, v is going to be equal to 4 times 25. This 100 minus 40 with that, right?
Yeah.
So what would this give you?
Negative 100 meters per second.
Meters per second. Okay. Meters per second. So we see what I just did over there. Even though I didn't know the answer for the velocity, I know what I should be expecting. So if it turns out that it's positive, then you need to check your work. It could be that it's correct, but that alone will function that, hey, mouse, check something. Maybe something didn't go, or you put something where you shouldn't have placed it or something. So it's always good to apply understanding when you are solving the question. It makes you check what you are doing right away. Is that okay, please?
Yes, please.
So the first question is down. Let's see if you can keep the momentum going. Up to the 10th question. So there's the second question.
Oh, no, that is going.
2016 winter 4-3, question number 5. There's our question number 2. A particle P starts from a fixed point O and moves in a straight line at time t seconds after leaving O. The velocity v meters per second of the particle is given by v is equal to 6t minus 0.3t squared. The particle comes to instantaneous rest at point x. Find the distance OX. A second particle Q starts from rest from O at the same instance as P, also travels in a straight line. The acceleration A meters per second squared of Q is given by A is equal to K minus 12t, where K is a constant. The displacement of Q from O is 400 meters when T is equal to 10. Find the value of K for 8. Let's get this one. Just like that. So any ideas as to how we're going to do this?
When they say instantaneous rest, it means velocity is equal to zero.
Yes, the velocity is equal to zero. It's at rest.
Mm.
At that instant, it's at rest.
Mm.
So any ideas as to how to start this?
So first I want to find the time taken.
Okay.
Yes. So I'll equate my velocity function to zero.
Okay.
Mm.
Okay. So doing that, what are you getting? Let me do
Okay, I
that.
got my time to be 20.
20. Is it
Yeah.
just 20?
20 seconds, sorry.
Only 20? No other number. Won't it be
No.
0 20? It's a
Yeah,
quadratic.
zero.
It's a-
Yeah, 0 and 20, 0 and 20.
What you are getting two positives. What does it mean?
So that means the object started from um I don't
Okay,
know,
so
like the object started from one point and moved to another.
so at the first instance, the object was at rest when the time was 0.
Yeah.
So initially the object started from rest. That is what it's telling you, the 0.
Oh,
And the 20 at 20 seconds again, the object was still at rest. So the object was at rest at 0 seconds, and the object was at rest at 20 seconds. Are you okay?
yeah.
Okay, so when v is equal to 0, I don't think I have to do the quadratic equation since we've done it. T is equal to 0 and t is equal to 20. So two positives, 0 is a neutral number. So two positives, at time 0, the object was with a velocity of 0 meters per second. And at time 20, the object was with a velocity of 0 meters per second as well. That is very good. But the question said we should find distance. So how will you find the distance?
So I'll integrate my velocity function. Then I'll
Okay,
use the two times that I got as my limit point
that is
and
very
find
good.
the distance covered.
Okay. So diva again, you differentiate displacement function to get velocity function. Differentiate velocity, get acceleration, and the reverse is with integration. So integrate acceleration function, you get velocity function. Integrate velocity function, you get displacement. Since the velocity function was given to us, finding the displacement function, s is going to be the integral of the velocity function, 6t minus 0.3t squared. So the object was at rest at this time. So the limit is 0 dt. And do you know how to use a calculator for this? You are not supposed to use a calculator for this, but I just want us to move faster.
Yeah,
Just
I've already solved it soon.
What did you get for an answer?
400 meters.
And that is correct. Okay, so with this and this, you know how to integrate this. 60, you integrate this one, you get, I think, 3t squared,
Yeah.
and you continue that way. And you substitute in your limits. Okay, let's see the question number 2, the second question. Any ideas as to how to go through with that?
Okay.
So a second particle starts from rest.
Mm.
Any ideas as to how to take that one?
100.
Which type of function is given?
See, acceleration.
Acceleration is given, and we are finding displacement. So the first thing to come in mind is we are going to integrate and do certain things, right?
Yeah.
Yeah. So even if you don't know anything, right, you know that there's going to be an integration.
Yeah.
With that, you definitely going to get some marks out of it. So you can get like 2 marks out of it, even if you don't get the answer correct. So there is an acceleration function given. A is equal to k minus 12t. Integrating the acceleration function, you get a velocity function. So integral
Mm.
of k minus 12t with respect to t, this should give you a velocity function. So v is equal to kt minus, I think this should be 6t squared plus v naught. Are you okay with that?
Yes.
The initial velocity was at time when t is equal to 0, the velocity was 0.
Yeah.
You solve for this and you still end up getting v naught equal to 0. I think we've gone through this already.
Yeah.
Should I still write it like v when t is equal to 0, v was equal to 0? And this is coming from this statement from rest, started from rest.
Yeah.
Coming from this statement. Is that okay?
Yes.
So this will get you a final velocity function as kt minus 6t squared plus 0. I don't need to write the 0 over there. What's next?
Then we integrate it one more time again.
We integrate it one more time to get the displacement function.
Yeah.
Okay, so using the displacement function, s is going to be equal to s is going to be equal to integral of why is my writing weird? S is equal to integral of kt minus 6t squared. Yeah. Now we're told that when t is equal to 10, the displacement is equal to 400. How do you take this one? How will you take this one?
So at time 400, wait, during 10 seconds the displacement was 400, so we integrate the whole thing, then we input those values into it.
Oh, really? Okay, that is one way, but that's how to see it. You see, between 0 and 20 seconds, the first question we saw, between 0 and 20 seconds, you introduce a limit, right? 0 and 20 seconds. So
Yeah.
between the 0 and 10 seconds, I can say that this should be 0 and 10. And the answer after differentiating this should be equal to 400. So that I don't worry myself with constant values, constant of integration and other things. Because
um
I'm setting this up as a definite integral question. So between the 10 seconds, that is 0 to 10, this is going to give you the displacement. Do you agree?
yeah.
Okay. So between the 0 to 10, the displacement is 400. So you take it out from there. So let's do the integration together. Let's- We are finding the value of k. So s is going to be equal to k over 2 t squared minus, I think this should be 2t cubed. So if you differentiate this, you're going to get 6t squared. Yes. And this, we integrating over the limit 0 to 10. This is going to be equal to 400. Derek, are you getting what I'm doing?
Yeah.
Okay, good. So I think you can continue from there. So at this point, I can say that t is 10. So k over 2, k over 2, yeah, k over 2 multiplied by 10 raised to the power 2 minus 2, 10 raised to the power 3 minus 0. It doesn't really matter. It's equal to 400. And I think you should be able to solve from here.
K is 48.
Good. Solving that, you get k to be equal to 48. And that answers the question. So that's our question number 2. Any question with this?
No.
Okay, that is very good. So we're done with the 2. We're done with the second question. 2 out of 10. Let's go to question number 3. 2016 again. Then the 2016 questions are very easy because the first 3 easy questions, the questions I rated as easy, are all 2016. So 2016 winter 4-1, that is question paper 4. The paper 4 is mechanics and 1 is the variant. It depends on the country writing that paper. So we've got variant 1, variant 2, and variant 3 for mechanics. Question number 3. A particle P is projected vertically upwards from a point O. When the particle is at a height of 0.5 meters, its speed is 6 meters per second. Find I, the greatest height reached by the particle above O. I, the time after projection at which the particle returns to O. That's a nice question. How would you categorize this question under kinematics?
We
Kinematics.
can make it I think
Which
2.
type of kinematics is that?
And this one is free fall.
Free fall, vertical motion. Okay,
Yeah.
vertical motion. That is very good. Now, which type of vertical motion is that? From what I've taught you, you know, I
Is the
categorize.
yeah.
Is
Is
it
the second one.
the second one? Okay. Okay. So let's try to get a picture of this. Let me use what's projected from a point above the ground. So from this side to this side is 0 point. To this side, it's 0.5. 0.5 meters. There is a particle. It was projected with a speed of, I think you can handle it, right? You should be able to handle it.
Mm.
It was projected and gets to this point. Okay. Okay, so let's set up the SUVAT for this. Let's set up our SUVAT. What is going to be the values of the SUVAT? Let me just set it up. All right. What is S? What is V? What is U? What is A? What is T?
Okay. I wanted us to treat it like we ignore the
The height given.
0.5. Yes.
Okay.
So then we'll make, because they said the greatest height reach, That means like maximum height. That's when velocity is 0.
Okay.
So here we'll use the 6 meters per second as our initial velocity.
And that is where we going to get it from. Derek, do you know this question is telling us that when the height of the particle, when the particle is at a height of 0.5, its speed is that. So
Yeah.
actually, this is not a type 2 question. This is not a type 2. It's actually type 1. It's projected from the floor. But when the particle has traveled 0.5 meters upwards, the velocity
Yes.
is 6 meters per second. Are you getting me?
Okay. Yes.
But I get what you're saying, but my diagram over here is depicting a type 2 kind of free-fall question, but this is not a second variance free-fall question. It's
Mm.
actually being projected from the ground. So this was the actual projection. Let's say it was projected at this point. But when the particle got to this side, the velocity of the particle now was 6 meters per second. Are you getting me?
Yes.
So let me set up the feedback for you. The feedback for this one is going to be first, we don't know the speed of projection. The distance I think it was above to attain this velocity was 0.5 meters. And at that stage, the speed of the particle is 6. In this case, that becomes a final 6 meters. And the U we don't know. The A we know is going to be negative 10 because it's going upwards. Now you can use this to find the speed at which this was projected with. That is the U. Is that okay, Derek?
Yes. Sir.
Okay, so with this one, which of the Silvert's equations are we going to use? I want U. I think V squared is equal to U squared plus 2AS.
Mm.
So V squared, let's use V squared is equal to U squared plus 2AS. So the V over here is going to be 6. 6 squared is equal to U squared, which we don't know, plus 2 of acceleration is negative. How interesting. And the 0.5. Okay. I think there is something that is going, it's not going well over there because you're going to get a negative root which shouldn't be so. Are you getting me?
Yeah.
You are going to get a negative root which shouldn't be so.
But sir, so can't we do it like the way I was saying?
Okay. You're not going to get a negative root actually. I thought I was going to divide through by this. I thought I was going to divide by this. So you're not going to get a negative. So this is going to be 36 and this will be plus. Are you getting me?
Yeah.
I was like I was going to divide through by 2 times negative 10, blah blah blah. That would have caused us getting a negative, which would have caused everything to be wrong. So this would be 2 of 10. Let me simplify first before writing all this. So 36 is equal to U squared. So do the calculation for me. This should be negative 5 times.
It's 46.
Is it 46?
Um, sorry, U squared is supposed to be
U squared is
46.
equal to
Okay,
46. And U will be equal to square root of 46.
yeah.
And this will be approximately equal to
6.78.
okay, 6.78. So that gives us the speed at which the particle is being projected with. So U is equal to 6.78. Now we solve the question from that angle. Is that okay, Derek?
Yes, sir.
Okay, so let's now solve the question. We've gotten the initial what is wrong with me today? Okay, we've gotten the initial velocity to be 6.8. I can now set up a new subart. Let me use a different name for that. So a new subart. The initial velocity is now 6.78. But because this is not our final answer, I'm not going to approximate to 2 decimal places. I think I once told you about errors when it comes to mathematics, right?
Yes.
So let's approximate to at least 4 decimal place. This is not our final answer.
Okay,
So,
so
so
six
that's what,
point seven eight two three.
okay, 6.7823. Even if possible,
Eight, yeah,
8,
7, 8.
7, 8. Okay, if I'm doing my own calculation, I would have used the entire figure over there. I would have used the square root of 46, but don't worry, we can go with this one. So there's 8. Good. Now, at maximum height, what can you say about the velocity?
Is 0.
Is 0. And the acceleration in this time is going to be negative 10. It's going upwards. The particle is going upwards.
Mm.
Okay, so we're looking for the distance from this side way to the ground. But I think what we were saying too would have made a lot of things.
Yeah, so I solved this. So I want to see if this one will and give us the same answer.
Let's see, let's see. Yeah, I think that would have been even shorter. We're going to use s equal to v squared equals u squared plus uas. V squared is equal
Yeah,
to u squared. Because 3 marks for this entire step is a little bit somewhere. V squared is equal to u squared plus 2as.
yes,
So 0 squared is equal to square root of 40 squared,
yeah.
square root of 46
Root
squared is going to be
46. Yeah,
yes, plus 2. The acceleration is negative 10.
yeah,
S is S, right?
yeah.
So this becomes x is equal to 46 divided by 3.
That's 2.3. It's the same thing I got when I did.
Yes, yes. Actually, I didn't really see it the way you were looking at it. Sorry.
Mm.
So actually, I wasted my I wasted the time because I think looking at the question that way would have made things very very easy. You don't need to find the initial velocity. You could have set up the question like a type 1 question where it's being projected from this level. In this case, the initial velocity over there is 6 meters, and the at the maximum height velocity is 0. Yeah, yeah.
Yeah,
Yeah. Sorry, my bad. That's actually for me. Then after getting the distance, you would have added it to the 0.5. Are you getting me?
yeah. Yes.
After getting this distance, I'm very sure you're going to get something like 1.8 something. Yeah,
Yeah, I got 1.8.
1.8, and you would have added it to 0.5, and that would
Mm.
have been a shorter procedure.
Mm.
Yeah, I'm kind of disappointed in myself because I always go for the shortcut. So I don't know why this question I didn't really see the shortcuts over there. Well, I can't really see all shortcuts. So,
Mm.
but it means that you're actually getting what you are doing. Yeah, if you can see a short way from a long way, that is very impressive. I'm proud. So let's find the time after projection at which the particle returns to O. So with this one, I only need the time from this side to this side, then multiply by 2.
Yes.
Are you getting me? Because I
Yeah.
think one of the sessions we proved that the time at which it takes the particle to get to the top and return to the
Will
same
be the
position,
same. Yeah.
yeah, it's going to be the same. So let's find the time from this part by using v equals u plus 80. I can use v equals u plus 80. Let me use a different color. V equals oh, I can see the white. Can you see the white? The yellow. It's some way.
Yeah.
V is equal to u plus 80. Sorry. So v is 0, u is square root of 46, the a is negative 10, and the t is t. So this becomes t is equal to square root of 46
Yeah.
divided
Over
by,
10.
then the total time is 2 times of this. So the total time will be equal to 2 times square root of 46 over 10. And this will be equal to, let me shift this upwards. This should be equal to square root of 46 over 5 seconds.
Yeah.
I like exact figures. But I can change this to anything you want. Yeah. And I use b equals u plus 80 and I'm getting 1 only one answer. But I could have used UT S equal to UT plus half AT squared. With that,
Hmm.
I'm going to, how many answers am I going to get for that? The T.
The T, you get 2.
Two. Okay. Two. And can you predict what one of the time will be?
0.
Zero. Yes. At this point, the time was zero. So Derek, you see the same question, the
Yeah.
second part. I want you to model the SUVAT using displacement, the only displacement. Let's see what are you going to do it. The same question that we saw. That I got a T to be equal to 46 with 46 over 10. I want you to model the same question using a different SUVAT. By this time, you are putting the displacement under consideration. Something that is going to get the time straight away without multiplying it by 2. Are you getting the question?
Uh,
The particle is going to return to its original position. Can you model a
yes.
SUVAT?
Okay. Let me
Okay.
see.
Do that for me. We'll do it together anyway. So that is just by the way. I just want you to master all fields so that you won't be surprised when you see a question. You know, I like to talk a lot too.
Hmm.
I like to talk a lot. When you're making the grades, I'll be like, hey, you know, I taught this guy, blah, blah, blah. I'll talk, sir. Yeah, so my responsibility is to give you the training you need to make the grades. Okay, we should be done with the SUVAT over there. Let's not.
Yes.
Okay, what is the S over there?
4.6.
Why are you using 4.6?
Because you want to, that's the total distance it will travel from the point of projection to it falls back to the ground.
So it falls back to the ground. Actually, it will be zero. Derek, where's your kinematics? That is
Displacement.
yes.
That's distance.
Yes, we are talking about this time. You see, Manyao, it's okay. I've gotten you. So the displacement over there is zero. With this one, the displacement is zero. The acceleration is negative 10. The particle was projected upwards, so it's negative 10.
Yeah.
The initial velocity of the particle, I think that one was root of 46.
Yes.
6. Now, from this, we can use any of the blah blah. So what's equal to UT plus half AT squared? That is the best to use. In this case, S is 0. U is square root of 46. Not 40T.
Hmm.
40, 46. So 46T, square root of 46T plus 1 over 2. Acceleration is negative 10. And the time is T squared. So 0 square root of 46 T minus 5T squared. Just use the calculator for this so that we get a straight answer. Okay, I don't want
Okay.
us to. But you know, something like this, you need to solve it in the exam.
Yes.
A simple way to solve this is not to really look out for factors. Just out one of the T out so that you
Hmm.
get a linear equation later. So 46 5T. Then you equate this one to 0, equate this one to 0. Like we said, one of the time is going to be 0.
Hmm.
And root of 46
Over
equals
5.
5T. So you can see that this one is getting me the answer straight away without multiplying it by 2. And I told
Hmm.
you that is the way I will do it most of the times because I like to save time. So I don't know what's came into me today and I was using a long process. So the answer we got over here, this answer is the same as this answer. But this one I was modeling this using displacement of 0. But you were using a displacement of
Hmm.
displacement and distance. They are not the same. Why? Please, they are not the same.
Hmm.
Or something like this, if you do it in an exam, they will blast you. Hey,
Hmm.
was this shouldn't be a mistake that you should commit. You get me right?
Yes.
It shouldn't be a mistake you should commit. I know certain mistakes when you commit them, yeah, it's normal. At times the question can be a little bit tricky, but avoidable mistakes. Oh, geez. Like I'll blast you.
Hmm.
Okay. Anyway, let's move on. That is the third question. You can see that this question was a little bit complicated as compared to the other one. Yeah, this looks interesting. Question four. Which year is this? I didn't have the year. Oh, all sad. I didn't add a year to this one. Okay. But I still think you can do something about it. So
Hmm.
I think this should be 2018 winter fall 2. Yeah, I think this should be 2018 winter fall 2. Let me just write the winter fall 2. Question number 3. Yes, I just saw it. Question number 3. Uh, it looks a lot. But I know you can do something about it. This is falling under graph aspect of kinematics. So the velocity of a particle moving in a straight line is v meters per second at time t seconds. The diagram shows a velocity time graph which models the motion of the particle from t equal to 0 to t equal to t, that is capital T. The graph consists of 4 straight line segments, so it means that everything is straight, there is no jet or dot over there. The particle reaches its maximum velocity v meters per second at t is equal to 10. Find the acceleration of the particle during the first 2 seconds. Find the value of v at t is equal to 6 or t equal to 6. The particle is instantaneously at rest at the point A. At t equal to capital T, the particle comes to rest at the point B. At t equal to 0, the particle starts from rest at a point 1/3 of the way from A to B. Find the distance of AB, hence find the value of t. Do you have any idea as to how you're going to do this?
For the first one, it will just be change in velocity over time. So a is equal to -2 minus 0 divided by 2. So that will be -1 meters per second square.
Oh,
Oh,
Derek, acceleration -1. Yeah, it's true that the gradient is -1, but it's
yeah.
acceleration -1.
In this case,
Acceleration being negative implies that deceleration.
yes.
So the acceleration is 1 meter per second.
So you said
The acceleration is 1 meter per second squared. Sorry, you were giving me acceleration as negative. That is what I'm talking about.
yes. So shouldn't we state it as the form it is in, or
So acceleration is just 1 meter per second squared. It says that you writing a is equals to -1 meter, you know it implies deceleration, right? So
or
Derek,
yes, I know.
yes. So this acceleration is 1 meter per second squared,
Hmm.
even though you're getting a negative value.
But
Okay.
doesn't it's but how getting this is doesn't it contradict to the diagram?
No. The diagram, the down part of the velocity time graph tells you that the particle is moving backwards, right?
Yes.
We started with the acceleration time graph, velocity time graph. I was like, the top part, this line implies acceleration. At the bottom part, this is the line that implies acceleration. A line with a negative gradient implies acceleration when it comes to the bottom part of the velocity time graph. Do you remember that?
Yes.
So this one is just indication telling you that the particle is actually moving backwards. The particle at this point has got a negative velocity. The particle is behind its initial position. So this is just telling you the direction, but it's moving. Okay, so let's say that this me. This is my forward movement, and I'm now moving backwards. I'm moving backwards, but I'm increasing in speed. I'm moving towards this direction now, and I'm increasing in speed. So my acceleration, even though the velocity is negative, the acceleration is still going to be positive. And negative acceleration, negative 1 meter per second square, it means to any mechanics teacher, this tells the teacher that the particle is reducing speed. Reducing speed.
Okay.
The speed of the particle is decreasing. A negative acceleration implies that a decreasing speed. So I know this is aligned with a positive gradient, sorry, a negative gradient, but we know the idea of acceleration and deceleration. The rate at which the particle is, the speed, the change of speed of the particle is 1 meter per second squared. Is that okay, please?
Yes, please.
Okay. So continue.
Okay.
But I do get where this is coming from. I do get where it's coming from. It's coming from the line. Mind you, you are not doing algebra. In algebra, if you tell me that the gradient over there is positive, you'll be large because that line is a negative gradient. It's a line with a negative gradient. So the gradient is negative. But this, unfortunately, is at the other side of the graph. I think this is the very first time you're meeting a question like this.
Mm.
Yes, yes. So that is the essence of solving the past question. Come across new questions. So if you meet a similar question, right?
Mm.
Okay. So like I said, the difficulty level of the questions are actually increasing. You see the first question, you didn't really ask a lot of questions over it.
Mm.
Yeah, but the difficulty level is increasing. Okay, find the value of V. Have you been able to do that?
Yeah.
Any idea as to how to do that?
Um.
Okay, should I come in?
I want to look at it. Just.
Okay. This is going to take a little bit of algebra, the understanding of algebra and straight line and gradient. Gradient implies inclination of a line, right?
Mm.
Okay. So the gradient at this point, if I'm taking this point to this point, if the gradient of this line is from this point to this point is 8, and this is coming from the same line, I can say that the gradient from this point to this point is also 8. Are you getting
Yes. Yes.
Okay, so if that's the case, then I can say that the gradient from this side to this side, which I've got all the values necessary to calculate the gradient, will be the same gradient from this side to this side.
Mm.
Are you getting me?
Yes.
Okay. So with this one, the gradient of this line is going to be, I think, 1 again, or am I mistaken? The gradient
Yes.
is 1.
It's
So
one. Mm.
m is equal to 1. So the gradient over here, m is equal to 1. And we know with this one, I can also find the gradient from this point to this point. So 1 is going to be equal to the change in velocity, v minus 0. I'm taking this triangle under consideration. If you remember your coordinate geometry, do you remember your coordinate geometry for mat D?
Yes.
Okay, so taking that under consideration, it becomes change in velocity. This is v, so the coordinate over there is v. Sorry, it's 10v, and the coordinate over here is 60. Are you getting me, please?
Yes.
So changing y over changing x. Changing y is going to be v minus 0, and changing x is going to be 10 minus 6. Then I think if you do your manipulation, you should get v to be equals 4. Yeah, v is equal to 4. Is that okay, please?
Yes. Say,
Okay.
wait, can we
Can we use the entire value straight away? Is that what you're going to ask?
yes.
Okay. Definitely we can. I don't really need to find a gradient and use it. I just didn't want the explanation to be what's the name? Complicated. So this coordinate is actually 4 and -2. But still we need to find a gradient. We still need to find a gradient. So the gradient from this side to this side will be 1, and we use that and we're going to get the same answer. You can try that and see. You're going to get the same answer.
Mm.
Is that okay, please?
Okay. Yeah.
Okay, that is very good. Let's see if we can continue with that. At t is equal to 6, the particle is instantaneously at rest at point A. At t equal to t, that is capital T, the particle comes to rest at point B. At t equal to 0, the particle starts from rest at a point 1/3 of the way from A to B. Well, this is what made me put this question at that level. It's interesting the way you're going to look at a question and grasp it. What is the meaning of that? What is the meaning of that statement? If you are not able to decode that statement, I don't think you'll be able to solve that question.
Which part?
The second part of the question, let me scroll up. The second part of the question, from this side,
Okay.
at t is equal to 6, the particle is instantaneously at rest at a point A. At t equal to capital T, the particle comes to rest at the point B. So let me name the parts on the diagram so that it becomes easy for us. Let's use a nice color. So at t equal to 6, there's point A. The particle is instantaneously at rest at point A. At t equal to
Okay.
the particle is at this side, B. You have to find the distance AB. The information we're given is that at t equal to 0,
Okay. Yeah. I see.
at a point 1/3 of the way from A to B. So the distance of this
Mm.
is actually
It's
one
one
third.
over three of the distance of A to B.
Yes, the distance of A to B. So I think we can use something to we can find the area of that shape.
Yeah.
I think after getting the area of the shape, I can just get the area of this one.
Mm.
I've got all the values to find the area of that. But unfortunately
The area
for
is 6.
the area is 6.
Yeah.
Okay. So how okay, the area over there.
Okay. Wait. Let me see. Sorry. Sorry.
I don't think it should be 6. I can't find the area of the triangle because the t, I don't know the value of this t. So I'm going to use the note given to us that this distance is actually 1/3 of the distance I'm looking for. So if I can find this distance, I can find the total distance I'm looking for. So let's find that
Okay.
distance.
So
The
it's
area of
A.
the trapezium over
Okay.
there.
A.
So S is equal to the area of the trapezium. In this case, it's going to be 1/2. The sum of the parallel sides. This is going to be
8.
6.
Yeah.
Okay, I think it's 8. 6 plus 2 times 2. I'm
Mm.
not using -2. Why?
Because the negative, that one is just for direction. So here it's not really needed.
So there's 8 meters. And do you remember the other time I was like, displacement. Actually, the in actual sense, there should be negative. If I'm talking about displacement, I'm just talking about distance. That's why I didn't. The explanation it gave wasn't right. I'm talking about distance, not displacement. That's why I didn't
Yeah.
use a negative. Now,
Mm.
assuming I'm talking about displacement, I would have used a negative. You remember there was a time I was like, with the velocity point graph, you asked when is the displacement different from the distance. I don't know if you remember you asking me that
Yeah.
question. I
Yes.
told you that when the diagram falls below the x-axis or the time axis, that distance is negative. It's going to cancel out and you get your displacement not to be equal to the distance. But this
Yeah.
one, the question was talking about distance. So the distance is that I can't use negative for distance. And you should know by now. Okay, so if 8 meters is one third of this, what is the total distance?
It will be 24. That's 8 times 3.
So total distance, the distance of AB is going to be 8 times 3, which is going to be 24. Now, with this value, I should be able to calculate the value of t. After all, the area of this is 24. Are
Mm.
you getting me?
Yes.
Okay, so let's do that one. Let's find the area of that shape. Or I'm going to use, okay, let me do it at this. Okay, that is a triangle. Area of a triangle is 1 over 2 BH. So we should be able to do justice to that question. So the 24, that is the distance. 24 is going to be equal to how do you times height? 1. The base, what is the base?
The base is 4. I thought the first triangle.
Yeah, the triangle. Not the first, no, I'm doing the entire triangle.
I are doing okay, and we have the height. Okay. The base will be t minus 6.
So t minus 6 times the height of this, which is 4. So you can do a manipulation and do justice to this. The 2 cancels this 2, and the 2 also cancels this. This is 12. So 12 is equal to t minus 6, and t is equal to 18. Is that is that correct? Yeah, I think it's
Yeah.
correct. T is equal to 18 seconds. So you see the kind of reasoning over there. You would have gotten the first one wrong.
Mm.
The second one took you a lot of time to figure that one out, right? I think it took you a lot of time to figure that one out.
Yeah.
Next time, if you come across such a question, you should know that you can apply the basic knowledge in your Math D or the additional mathematics to continue. And from this side, it's all English. It's all English. If you don't really understand the English, the math out of the English over there, you won't be able to solve the question. That is one third of the blah blah blah. If you don't really understand the
Mm.
math out of the English over there, it's going to be a problem for you. Okay, so that's for that question, and the difficulty level keeps rising. So that's question 4. Question 4. Let's see question 5. How many minutes have we got? There's 7. My time is almost up. Okay. Question number 5. Question number 5. I think this should be easy. I think we've done something like this before. Or we'll try it.
Yeah.
The particle, sorry, a particle moves in a straight line from point O with initial velocity 1 meter per second. The acceleration of the particle at time t seconds after leaving O is a meters per second squared, where a is equal to 1.2 t raised to the power 1 over 2 minus 0.6 t. I, at time t seconds after leaving O, the particle reaches its maximum velocity. Find the value of t for 2 marks. The next question, II. Find the velocity of the particle when its acceleration is maximum. You don't you do not need to verify that the acceleration is maximum rather than a minimum. You don't need to verify that. Verify that. It's not important. Okay. That one is it's more of art maths.
Mm.
Or let me say pure maths because you now over with art maths. So it's more of pure maths. Is there any initial condition there? Derek?
Yeah. Velocity is 1.
When t is equal to
When t is equal to
when t is
0.
equal to 0, velocity is equal to 1. Yeah,
Yeah.
that is the initial condition, and that's coming from the side. Its initial velocity, or you can start with v naught is equal to 1. But this, like I said, it can create problems for you. So normally write out the initial velocity. Okay, like
Mm.
write out the was the IVP, the conditions given, the initial conditions given.
Mm.
Okay. Again, this is a calculus question. Diva, and you know this if there's a calculus question when you see a variable t in the question, that is you get a function like question. It's a calculus that you're going to use to continue. Now we've got acceleration function. We're looking for velocity function, maximum velocity. So at maximum velocity, what can you say? So at max velocity, what can you say?
I can say displacement is 0.
At maximum
Hey, wait,
velocity,
wait, 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 wait.
I'm waiting. I'm still waiting. Maximum velocity.
Acceleration is 0.
There's no change in speed again. Acceleration is 0.
Hmm.
Yeah. Eric, what came into you to tell me that
I
there
don't,
is
I don't, I don't.
because maximum velocity, the particle is still moving with speed, like that is the maximum speed it can get to. And he's saying that the displacement is 0. Hey boy.
Hmm.
Okay, there's the acceleration. There's no change in velocity, so the acceleration is 0. Okay, with that I can just do my substitution and solve for that. Let me write this in terms of okay, let me just solve this. A is equal to 1.2, sorry, 1.2 t raised to the power 1 over 2 minus 0.6 t. I can factor out 1 over 2 t. So 0 is
Yeah.
equal to t raised to the power 1 over 2. I can even factor out 0.6. This question looks familiar. I think I've solved this before. Derek, I think we've solved this before.
Oh,
Well, that's what I think. What would this be?
which one?
I'm trying to factorize. So I thought you were going to assist me, but
Oh,
this is what I'm getting. So equating this to 0, I get t to be equal to 0. I don't need to solve that one. T is equal to 0. And equating that one to 0, I should get 0.2 is equal to square root of t. And t is equal to 0.4. Okay, so this is the time at which the velocity is at its maximum. But we're not done. We're told to find we're told to find the time at which the velocity is at its maximum. So we found that. Is that okay?
hey, yes.
Okay, so the
So
next
say,
part.
wait.
Mhm.
It's not supposed to be 0.2.
Oh really?
Yes.
What is this supposed to be then?
I think it's supposed to be 2 because it's 1.2.
Oh okay.
So your answer
Uh,
is supposed to be 4.
the answer is supposed to be 4.
Yeah.
Oh okay. Yeah, that is very true. Let me just explain this one. That is very true. So the answer is 4. My bad. So 0 and 4 seconds.
Mm.
Can we continue, please?
Okay.
Okay, so the second part of the question says that find the
Find the
velocity
velocity.
so when the acceleration is maximum. The velocity when acceleration is maximum. For maximum acceleration, what can you say? The first one,
Jolt or jerk is 0.
okay, or jolt or jerk or change in acceleration is 0. All of them are actually change in acceleration. So for max acceleration, change in acceleration, the ADT is equal to 0. So the ADT, we need to differentiate this. So the ADT is going to be 1.2, sorry, 1.2 times 1 over 2 root t. I told you there is a way to differentiate a radical function with ease. You'll be taught in pure math, so don't worry.
Mm.
Well, don't mind me, I'm just showing off small, okay?
Mm.
So there's 1.6 over t minus 0.6. This is equal to 0 because the ADT is equal to 0. So solve, oh, I think this should be 1. This should be 1. I don't need to solve this because it's only when t is equal to 1 when this is going to be 0.6 minus 0.6 and that should be equal to 0. So t is equal to 1.
Okay.
I don't need to solve this one. From my little knowledge in maths, I think I don't need to solve this one. Are you with me?
Yes.
Because it's only 1 when you substitute, like 0.6 over a number minus 0.6 is equal to 0.
And that will
So
give you 0. Yeah.
okay, so we've gotten the time at which the particle is at its maximum acceleration, but we're told to find the velocity. Find the velocity. So how are you going to continue on this?
So now we have to integrate the acceleration function.
Okay, okay. I need to get acceleration function. Okay, it's the acceleration function is a is equal to 1.2 t 1 over 2 minus 0.6 t. Lever, we're going to integrate the acceleration function to get a velocity function. So v is going to be equal to that's integral of 1.2 t 1 over 2 minus 0.6. So with this one, you get v to be equal to 1.2 t over 3 over 2 over 3 over 2. So let me just write that 3 over 2 minus 0.3 t squared, but let me just write 0.6 over 2 t squared plus v naught initial velocity, because this is not a definite integral question, so we need to add the constant of integration. Okay, let's continue. What is 1.2 divided by 3 over 2? Let's simplify it first.
4 over 5.
V is equal to 4 over 5. So I think 0.8 t
Mm.
3 raised to the power, sorry, t raised to the power 3 over 2 minus 0.3 t squared plus v naught. This is where the initial condition comes in. Do you remember the initial condition?
Yes.
Yeah. When t is equal to 0, the velocity is
V
equal to
is
1.
1. Mm.
Yes. So let's put in there. But we're going to get v naught to be equal to 1 anyway. So if you
Mm.
do that substitution, when v is equal to 1, t is equal to 0, you get v naught to be equal to 1. So the substitution is going to be 1 is equal to 0 plus, sorry, 0 minus 0 plus v naught. And v naught will be equal to 1. So from this side, I can write down my velocity function. Is that okay?
Yes.
Okay, let me just bring this. Okay, let's write out the velocity function now. Uh, sorry. I changed the size of my ink.
Mm.
Okay, let's do check. Okay, the velocity function v is equal to 0.8 t raised to the power 3 over 2 minus 0.3 t raised to the power 2 plus 1. We're told to find the velocity when a particle reaches its maximum acceleration. So the maximum acceleration, we got the time to be equal to 1. So we put that time over here.
Mm.
Got the time to be equal to 1. So v is going to be equal to 1 raised to the power any number is 1, so 0.8. Basically 0.8 minus 0.3 plus 1, right?
1.5. Yeah.
So go to 1.5 meters per second. And that answers that question. That answers that question. Okay. Is that okay, Derek?
Yes, sir.
So that was the fifth question. Now we've done so much. The sixth question, the difficulty level is different. This has increased. Rana start from blah blah blah. This is 2018 Winter 4-3, question number 4. 2018 Winter 4. It's not so difficult. We're going to solve the last two questions, then you solve the rest by yourself. Okay.
Okay.
So let's solve this question. Let's be fast about it. 2018 Winter 4-3 variant. Question number 4. Sorry. Uh, a runner sets off from a point P at time t equal to 0, where t is in seconds. The runner starts from rest and accelerates at 1.2 meters per second squared for 5 seconds. For the next 12 seconds, the runner moves at a constant speed before decelerating uniformly over a period of 3 seconds, coming to rest at Q. A cyclist sets off from P at time t equal to 10 and accelerates uniformly for 10 seconds before immediately decelerating uniformly to rest at Q at time t equal to 30 seconds. I sketch the velocity time graph for the runner and show that the distance PQ is 76 meters. This is easy. This should have been our first question. This is easy. It's actually very easy. Oh. Okay, so let's start with the velocity time graph. You should have your ruler and other things with you. So how are you writing the question? You just write
Is it?
the year, right, and you cross check the question, or you're
Yeah.
writing it.
No, I write the year.
Okay, so you just write the
Then
year.
like the main things inside.
Okay, so this my graph. There's my graph. I don't need a ruler. I can get diagonal lines. So a runner sets off from point P at t equals 0. You should know that with this kind of graphs, if you don't use a straight line, you're going to be in trouble, especially the displacement time graph, because you can represent acceleration and deceleration using curves on the displacement time graph. So you have to be very careful. Let's get this curve. A runner sets off from a point P blah 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 seconds. The runner starts from rest and accelerates uniformly at a rate of 1.2 meters per second squared. So let me get my diagonal line. So this is where the runner starts from. So let's say he ends somewhere here. And the rate at which this person is going is 1.2 meters per second squared. So that becomes a gradient.
Mm.
Okay.
Yes.
So can you walk me through the next step? What are we to do? What is the line?
So let's the down line will match to 5 seconds.
Okay.
Mm.
Okay. Because the velocity wasn't given, I think we can't do anything about it now. So what we can do is just write v seconds over there. And that's just fine. Okay. Let's continue with the graph.
Okay. Then they said for the next 12 seconds the runner moves at a constant speed, so straight line to 17.
Okay. So 17 seconds. Okay. Okay, continue.
Then before decelerating uniformly for a
So
a
decelerate.
period of period. Okay, yeah. So curve negative slope
Kevin,
to
Derek, we are on a velocity time graph, not displacement time graph.
I said slope. Sorry. Yeah.
We were saying a curve. A line, there's going to be a line with a negative gradient.
Yeah.
Yeah, yeah. Is that what you meant? Or
Yeah. I said a line with a negative slope.
okay, okay. Sorry, I took it as a curve. Sorry,
Yeah.
sorry, my bad. Okay, so
So
this is going to be
20.
what is the total time?
So it'll be
20.
20 because it's 3 seconds. Yeah.
Okay, okay. So that is going to be 20. Okay. Now we're told that we have to show that this is 96. Any idea to how to do it?
Okay, we can use. Okay, we don't know. We can use the acceleration given to find the v.
Okay, so let's find it. V, so 1.2 is going to be equal to V over 5.
Yes.
Yes. Oh, okay. Y V over 5. And V is going to be equal to
6.
6. 6 meters per second. Now, what
Yeah.
is the next?
So they said we should find show the distance, right? That is 96. So
Yes.
we can find area of a trapezium, which is
Okay.
like area under the graph.
It's going to be the area, which is
Yeah.
going to be 1 over 2. The sum of the parallel sides.
Yeah.
This case is going to be 20 plus 20 plus what?
20 plus 12.
20 plus 12 times the 6 we found.
Yeah.
So, you calculate this and definitely you are going to get 6. If you are very sure of what you are doing, you just write the answer about it after it the proof. The question is telling you
Yeah.
that the answer is 96. So if you solve and
Yeah.
you get something different, you should know that you are wrong. That is
Mm.
one thing I like about mechanics proofs. And it's so frustrating when you're not getting it right. So just
Mm.
imagine you know the answer, but you're not getting it right.
Hmm.
Very frustrating.
Mm.
Okay, let's continue with the question. So
Mm.
we've proven that it's 96 meters.
Yeah.
We have to find the magnitude of acceleration of the cyclist. So at another point, someone cycle, I don't know. So a cyclist is a bicycle, actually. What am I? Okay, a cyclist, blah blah blah. Let's try to sketch a velocity time graph for the cyclist. Is it
Yeah.
okay? Trying
Yes.
to but I think that is going to go a long way to assist us in our question.
Yeah.
So a velocity time graph for the cyclist. A quick one. So the cyclist started from
Point P, the simply.
the same place.
Yeah.
Okay, 10 seconds after. So there's 10 seconds. That's where the cyclist started from.
Yeah.
Okay. And accelerated uniformly. So let's say accelerated to the side and decelerated immediately to the side. So basically, there's the position of the cyclist. Are you getting me?
Yes.
Okay. So with this one, it did it in I think in about 10 seconds. So this would be 20, and this would be 30. The total time used by the cyclist was 30 seconds. Is that okay, please?
Yes. Yes, please.
What's the total distance traveled by the cyclist?
The total distance.
Mm-hmm.
uh, It will be the same 96.
Good. It's
Oh,
really the same
yeah.
96 because they are both traveling the same. They are covering the same distance. It's just
Mm.
that someone is faster than the other. One person is faster than the other, so
Mm.
it's going to be the same distance. So with that, I think I can find the acceleration and velocity at which this was traveling. The
Mm.
cyclist was traveling at. Is that okay?
Yes, please.
Okay. So let's do something. Let's find the velocity.
Yes.
Go quickly. Okay, so the velocity, now I can say that 96 is going to be equal to half base times height. The base is going to be 30 minus 10, which is 20. 20 times the height is v. So you do your manipulation and you get the value of v.
Yeah, it's 9.6.
Okay, so v is 9.6.
Yeah.
So what else? We have to find the magnitude of acceleration. Okay, now that we've got the value of v, I can indicate everything over there. So at this point, it was 20, and the v is 9.6. And at this point, the coordinates, I'm just writing the coordinates down. So it's
Okay.
going to be 10 and 0. So the acceleration is going to be the gradient of that line. So
Yeah.
change in y, 9.6 minus 0 over change in x, 20 minus 10. This should simplify to 9.6 over 10,
0.96
0.96 meters.
meters per second
Well,
squared.
this question wasn't so difficult. Did you find it difficult?
No,
It wasn't so difficult. Okay.
I
So I
think it's
think
because we drew it, so it's made it clearer.
if we didn't draw this diagram, it would have been very, very complicated.
Mm.
And interestingly, people will start using silver for this. This is going to complicate things. When you get a question and silver is not working, please try to sketch it. Okay,
Mm-hmm.
try to sketch it. At times, silver won't come to the rescue. I think so far, we've not solved any question under silver. The only silver question,
No, the only
oh,
one was I think we did one. Oh,
it was free fall.
okay, yeah, yeah, it was free.
There is no like horizontal motion. It's not solved
Yeah.
any question under horizontal motion so far. So that's question number 6. Question number 7. Okay. Oh, question number 7 too is vertical motion, but it's difficult. So, like the difficulty level, it's question 7. So just imagine.
Yeah.
A ball is released from rest at the top of a tower, and then 1 second later, another ball is projected vertically upwards from the ground level near the bottom of the tower with a speed of 20 meters per second. The two balls are at the same height 1.5 seconds after B is projected. Show that the height of the tower is 50 meters. And the second part of the question said or says that we should find the length of time for which the ball B has been moving. Oh, okay, yeah. When this, yeah, this is why the question is actually at question 7. I was wondering why vertical motion question would be at question 7. Yeah, because vertical motion, but it's not so difficult unless maybe it's combined with other things. When you go to school, try your best to solve your seniors past question, the mechanics.
Mm-hmm.
The vertical motion that was combined with momentum. The question was crazy. Hey, the question was so interesting and so difficult. It wasn't difficult too, but for me, I like the difficulty level plays in that question and the kind of reasoning and thinking you need to put into the working process. Otherwise, okay. So let's solve this question. Let's solve this question real quick. Let's set up the subat. So let me use red ink for ball A and maybe other ink for ball B. For ball A, setting up the subat. Let's set up the subat for A. So what is
Okay,
going to be the initial velocity for A?
0 because it said release. No, wait.
Yeah, release from rest.
Yes, yes. Because this one they are dropping it, so it can be 0.
0. But it can be dropped with a speed as well. A ball
Then
can be dropped.
is that dropping it? Aren't you throwing it downwards? Oh,
Yes, it's the same. Like it's the same model. The modeling, you see, it's going to be the third model.
oh,
I
yeah.
So it's not always zero that can will be the case. Okay, so
Mm,
at times you can get something that is not zero. I'm just trying to tell you. So in case that you get a question like that, it won't really surprise you. But you
okay.
can't get a question projected from the ground and the speed is zero. I think I did explain that to you why that
Yeah.
can be. Yeah.
Yes.
Okay. The A is going to be 10 because it is going downwards.
Yes.
What's
Then
up?
T will be 1.5,
T 1.5.
and we can make the S X. Yeah.
Let's leave the S as S that way.
Okay.
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 Good. So are you sure the T is going to be 1.5?
Wait.
Let's read the question again. A ball is released from rest at the top of a tall tower. 1 second later, another ball B is projected vertically upwards. So 1 second has passed before the second ball is being projected. So there's the red ball. It was projected, and 1 second later, and that ball was projected. And 2 seconds, 2.5, sorry, 1.5 seconds later, they both are at the same level.
Mm,
So I can say that the time for T when they are at the same level is going to be 2.5 seconds. I'm modeling this when they are at the same level. So the time for T is going to be 2.5. That is the time it was projected. 1 second later, this was projected, and it took 1.5 seconds for them to be at the same level. So ideally, when both the two balls became at the same level, the red ball A would have traveled 2.5 seconds.
okay.
I guess
Yes.
so there's 2.5. So that is for A. Let's model another one for B using a different. So B, the suivant for B, the suivant for B. Okay. So B actually traveled how many seconds?
Um. That one will be 1.5.
That one will be 1.5. The initial velocity will be
20.
20, and the acceleration will be
-10.
-10. Good. So do the manipulation for me. Calculate for S in both cases because we're looking for this.
Okay.
Calculate for S in both cases. So you can use S equals to UT plus half AT squared.
Mm.
S equals to UT plus half AT squared. Well, let me use whatever you use. So S equals to UT plus half AT squared. Well, that's when yes, we work. U is 0, so S equals to 5. Acceleration is okay. 2.5 squared. Hope I'm right. I think I'm right. Yeah.
Mm. It's 31.25.
That's 1.25. So if there's a tower, this they met at a point when the red ball has traveled 31.25 meters. So let's find the distance traveled by the blue ball or ball B. Is that okay?
Okay.
So that is going to give us the distance from the ground to their meeting point. So from the top to their meeting point, that is the red ball, give us 31.25. So finding that for the blue ball, that is the ball B, we're going to use the same Suvat equation, S equal to UT plus half AT squared. S is S, U in this case is 20, the T is 1.5, 1.5 plus or let me say minus 5 so that I skip the step over there. Minus 5 times 1.5 squared. What would this give you?
18.75.
Come again,
18.75.
18.75. So it means that from the distance from the ground to this level is 18.75. So the total distance, the total height of the tower, what do you think is going to be?
It will be 31.25 plus 18.75. That will be
Oh, that's
50.
what you're told to prove. Yes, you're told to prove that it's 50. So that's
Yeah.
what you got. For total distance, the total distance is going to be equal to 31.25 plus 18.75. And I don't need to calculate this because the person is telling me that I should get 50. So that is 50. So that is this question. Now the second question is what is sending this to question 7, because it's quite interesting. Find the line. Find the length. Sorry, find the length of time for which ball B has been in motion when A reaches the ground. Hence, find the total distance traveled by ball B up to the instant when A reaches the ground. This is
Okay.
interesting. Any ideas as to how to do this?
Okay, so we just have to find the time it will take for A to hit the ground.
Okay.
Then we'll use it to help us find B, like the distance traveled by B.
Okay. So you're saying that you find a time for that is time for A to get to the ground.
Yes.
Okay. So how will you do that?
So the same thing, U is 0.
So we should
Um
do that.
yes.
Okay. Let me cut this question down. That's okay. Um. So for A, okay. We're saying that U is equal to 0
Yes.
and continue.
Display S is 50,
S is 50.
and then acceleration is 10,
A is 10.
then time is T.
Okay. Time is T. So we can use this to find T.
Yes.
By using S equal to UT plus half AT squared,
Yes.
we should get this. So 50 is equal to 0 plus, let's say 5. The A is 10. I've done that already. And T squared. So that's going to be 10 square root of 10. T is
Yes.
equal to square root of 10.
Yes.
Approximately, what would this be?
Um, 3.1623.
3.1623.
3.
Okay.
Yes.
So let me model. I don't want to be going up and down again. I Let me model everything over here. Is that okay with you?
Yes,
Like
please.
so there is this blue ball. Okay, let me draw the tower first. There is this tower. Um, let's say this. Is that even a tower? I don't know. Okay. Okay. So this is 50 meters. This is 50 meters. And a ball was dropped from this side. Blue ball. Blah 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 blah. And a ball. Well, that was a red ball. Oh, actually, that was a red ball. I was using the wrong ink. I was using the wrong ink. Okay, so a red ball was projected and the blue ball was also projected. The blue ball was projected from the ground. The blue ball traveled a distance of 18.7, and the red ball traveled a distance of 31.25. 31.25. Okay, so this the meeting point of the two particles. They actually no, they are not meeting. They are not colliding. Actually, if they are to collide, that will send you to something else. That was the question your seniors got. So this was a meeting point, and now we found the time at which the red ball. Sorry, this calculation was supposed to be in red. Let me just. So this should be in red. Don't let that confuse you. Okay.
Okay.
So there's 3.162. The time at which the red ball gets to the ground is 3.162. Okay. Now the question was saying something else. What the questions? What was the main thing about the question? We have to find the total time for which B has been in motion when A reaches the ground. So what do you think we're going to do about this one?
So what I was doing at first is wrong.
Oh, it's not wrong. It's not wrong.
Okay.
It's
So
one part of the question.
okay. So now that we found the time it took for the red ball to finally hit the ground, we can set up our SUVAT for the blue ball.
Okay.
Mm.
But we're looking for the time at which this was in motion when before before B hit the ground. That's the question. It's like you're not getting the question, Derek.
I think they say we should find the total distance traveled by the blue ball before the red ball hit the ground.
Total no, first we're told to find time. First we're told to find time. Let me go back to the question again. You're not getting the question. Let's read the question again. Well, it's difficult, so find the length of time. That is the first part of the question. For which ball B has been in motion when A reaches the ground. So A was projected, right? A was
Yes.
projected, and B was also projected. And we're told to find the time it's taking this when A was at the ground. The time it took this for A to get to the ground. That is the entire question. So first, he said you should find the total time taken. That is very good. We found the total
Mm.
time taken, and already. Let me go back to this. Let me just go back to my child size. Uh, okay, so already the particle had traveled how many seconds for this? At this point, I think the particle traveled 2.5,
2.5.
and this particle, the blue particle, what is the total time traveled by the blue particle? One.
1.5.
Okay. Now we got to know that the total time at which this gets to the ground is 3.16. So I can say that for this short distance, the particle is going to use 3.162 minus 2.5 seconds to travel the short distance. Are you getting me?
Yes.
So what is going to be that value? So the
Okay.
time for this distance, what is going to be that value? 3.16 minus that.
That'll be 0.6623.
6623. So let's say 0.662. 0.662. Now, for this time, this particle will still be going upwards. This particle will still be going upwards. So the total time for B will be the time it has traveled already, 1.5 plus the 0.662. So the total time for B. Are you getting me, Derek?
Yes.
Okay, so the total time in this case is going to be 1.5 plus the 0.662. And this is going to give us, I think it should be 2 point something, 2.1, 2.16. Is that okay? Because
Okay.
this plus this is 11, so 1, yeah, 2.162. So 2.162. So the total time for the particle to be in motion when this hits the ground is going to be 2.162. So the reason what I'm doing here is that I already know that when the red particle was in motion, this particle has traveled 1.5 seconds already. Now the rest of the distance is small, and when this particle gets to the ground, it should have covered 0.662 seconds. So at that time, this particle is still going up. This particle is still
Yeah.
going up. It's
Yeah.
still in motion. I don't know whether it's still going up or it's on a return journey. But on a return journey, it's going to take it more than 3 seconds because from this side to this side, it's already one. Are you getting?
Yes.
So it's less than 1.5 seconds. I can say that the particle is still in motion. So we're told to find the time at which the particle is in motion when this hits the ground. So since this has traveled 1.5 seconds already, and it's going to take this particle 0.662 seconds to hit the ground, then the total time for this to be in motion when the red particle hits the ground is going to be the summation of the two values, and this is going to be 2.162. Is that okay, please?
Yes, please.
Okay, good. Now, the second part of the question, we have to find the total distance when this hits the ground. You have to find the total distance for this to hit the ground. Find the length of time. We've done that already. For week B, blah 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 blah. I can't. Okay, yeah, that's what I was looking for. The total distance traveled. We are told to find the total distance traveled by B up to the instant where A reaches the ground. And that is what is making the question complicated. Now let's think things through. There are two ways. There are not two ways, but there is a wrong way and there is a right way to solve this. Now I'll go through the wrong way first and tell you why that is wrong. Then afterwards we go through the right way. Is that okay?
Yes, please.
Okay. So for B to get to the ground, I'm going to do this the wrong way first, and I'll tell you why it's wrong. Then I do the right thing. For B to get to the ground, sorry, for A to get to the ground, it would have traveled. B would have traveled 2.162 seconds, right? So
Yeah.
the wrong thing someone is going to do is to set up the silver this way with an assumption that the particle is still going up, which is very wrong. So the particle would have traveled 2.16 seconds, and the acceleration of the particle is negative 10. Hello, there.
Yeah.
Okay. The particle is still
So I can't hear
negative.
you.
I think this we are given the initial velocity 20, or we're given the
You
initial
said
velocity 20.
okay.
Sorry, can you
Yeah,
hear me?
now I can hear. Yeah, I can hear you now.
20.
Yes.
Yeah, the initial velocity is 20. This
Yeah.
one, actually, what I'm doing is wrong, and I'll tell you why. Um, we find the distance travel. So we'll find the distance travel for me. So S
Um.
equal to plus RT squared. So there's going to be S equal to 20 of 2.162 plus, or let me say minus 5 of 2.162. So this is going to be a common mistake.
Um, that's negative 1010.6.
Oh no, I don't think so. You shouldn't get negative 1010.
No.
This is square though.
Yeah.
That's square. I don't think so. Try again.
Okay.
This is 20. This is 20 times this. This squared won't be more than 6. It should be like 5 or so. 2 squared is 4. Let's say there's 0.1416. Let's approximate it to 1. So that will be 5. 5 times 5 is 25. And this 25 is less than 20. This we shouldn't get a negative value.
Okay. 19.9.
19.9.
9. Yes.
7 meters. Okay, so there's a common mistake. That's why I'm saying there's a common mistake. You see, with this one, we're saying that the total time the particle has traveled is 2.162, which is very correct. It's very correct. But the question is, you see, we're talking about displacement and distance. When I project a particle and the particle is at this level, let's say that the height of this is, let's say, 15 meters. The particle goes up and come back to this level. The displacement of the particle is still 15. Are you getting me?
Yes.
Distance is not 15. Let's say that this side is 18. At this point, this is 18. The total distance is going to be 15 plus 3 plus 3, which is going to be 6 plus 15, which is going to be 21. But the displacement is going to be 15. The subat over there, the S over there is not distance. The S over there is displacement. So you have to be very careful. Now, the first question you need to ask yourself is, at what time is this particle going to return? What I did this with the assumption that the particle is still moving upwards. But the particle, I don't know if the particle is going to come down or still be moving upwards. So the best thing to do is to find the total time it's going to take the particle to 10, to start to 10. Are you getting me? So that I factor in the displacement factor. Displacement. Otherwise, I'll be finding displacement instead of distance. If I don't know the total time it's going to take the particle to 10. What if we're saying that the particle is moving upwards with spins 2.162 seconds up there? It could be that at this 2.16 seconds, the particle is on a return journey. So if this particle is on a return journey, using the 2.16 won't be an accurate value. So we're going to start off by first finding the total time is going to take the particle to start a return journey. So that is a maximum height. So for the there's the right thing now. So that the first thing I did was actually very wrong. I was doing that with the assumption that the particle is still going upwards. The subvert for this one, I'm going to set up this way. The initial velocity was 20, which we know. The final velocity, I'm looking for the maximum height is 0, and the acceleration is negative 10. So with this one, I can find the time at which the particle reaches its maximum height. Are you okay, Derek?
Yes.
So let's find v equal to u plus ad, or finally this mine. Okay, this is not my first time, but you can find this one. This 0 is equal to 20 plus negative 5. So let me just use negative 5t. So find this one for me.
So why do you make it negative 5?
80. V equal to u plus 80. The a is negative.
Yeah, but it's 10.
Oh, okay. Sorry. I'm so used to the half 80 squared. So okay. So I think
So
t
T
over
is
there is
5. 2, sorry.
2 seconds. So you see what I was talking about. The total time the particle has taken when B landed was 2.16 seconds, but the particle is going to use 2 seconds to start a return journey. Are you getting me?
Oh, yes.
So the particle for the next 0.162 seconds, the particle is actually coming down. So the using this value, we're going to get displacement instead of distance. The
Yes.
particle is come down, but taking out for the total distance traveled, not the total displacement traveled. So it means that the particle is going to use 2 seconds to get to the maximum height. So let's say there's the maximum height. It's going to take the particle 2 seconds to get to this side. Second, but the particle was in the air for 2.162 seconds before the red particle landed. Now, after the 2 seconds, the particle will be on the return journey. So first, let's find the distance covered, the total distance covered to get to this point. After all, that's what we are looking for. So
Mm.
let's look for the total distance covered, the maximum height. So I think we can do that with ease. So let's find the height. We found the time. I think I trust the time, so I can use the time to find the S straight away. So S equal to UT plus half AT squared. So S equal to UT plus half AT squared. I trust the time, so I'm using that. S equal to 20 times 2 minus 5 T squared. Or I
Yeah.
think we know the T.
Yeah.
We know the T to be 2. So
Two.
this is 4. Let me just write 2 squared here. Okay. If you manipulate
That's
this
20.
20,
Yes.
yes. It's 20, right?
Yes.
Okay. So the particle would have traveled 20 meters to reach its maximum height. Are you getting me?
Yes.
At this point, B has traveled 20 meters to the maximum position, and it will be on a return journey. Okay, so at this point, this particle will be on a return journey. After traveling 20, this and this is 20 meters. So you see the calculation that we did. You see the answer
Yeah.
we got. We got an answer of 19.7, 19.7, which is very wrong. But
Yeah.
so far, we are not even done with the time, but we're getting the distance to be 20. What we found was actually displacement. The displacement over there is correct, but the question is talking about distance. So we don't really need to use that straight away. So we need to do this bit by bit before we can get to our destination. Is that okay?
Yes, please.
Okay, so let's now factor in the time left to travel. So remember we said that the time the particle will be in motion when P lands as T is equal to 2.162. Is it 162?
Yes.
Okay. So the total time left for the particle to travel is going to be, so time left is going to be 2.162 minus 2. 2.162 minus 2. This is going to 0.162. So we're going to find the distance the particle is going to travel in this 0.162 seconds. And that is going to give us another form of question, a free fall question. So this is where the particle is at. This is where the particle is at. Now the particle is on a return journey. We want to find the distance it's going to take to travel 0.162 seconds. So I can set up a subart again. And with this one, it's like a particle is being dropped. So the initial
Yeah.
velocity
So 0.
is 0.162
The
and
acceleration is 10.
the acceleration is 10. So with these three values, we should be able to find S. So mind you, the particle has already traveled 20 meters already. Okay. Now doing this, I think you should be able to get the S by using S equal to UT plus half AT squared.
Yeah, it's 0.131.
So let me do the substitution. So 0, the 0, plus 5, the 8. Figure that one out. I factored in already. You said you got S to be equal to
0.131.
0.1. Are you sure? I don't think so.
That's it.
Because that's it.
Yeah, that's it.
0.13.
One.
Okay. So now let's go to the board again. That is the free diagram I was doing over here. So this diagram, let me use a different thing. The particle would have traveled 20 seconds from this side to this side. So the distance traveled is 20 meters. Sorry, 20 meters. Now the particle is coming down. For the next 0.126 seconds, the particle has traveled the answer you gave me.
Hmm.
Let me the answer you gave me. What was the answer?
0.131.
0.131. Okay. 0.131. So what is going to be the total distance traveled by the particle?
It will be 20.131 meters.
Total distance will be 20 plus 0.131, and that should give you 20 point, is it 20.1?
131.
Okay, 20.13, 20.131 meters. So that is the total distance traveled. What we found over there, Derek, mind you, this one is not so wrong, but this one is actually giving me the displacement. It's giving me the displacement. So subtract the time, the return journey, the distance we got for the return journey from the 20, and see what you're going to get.
Okay. Got 19.86.
19.86.
Yeah, 869. So 19.87.
19.87.
Yeah.
Okay. So you can see that this is very close. I don't know why the difference is there, but you can see that this is giving you the displacement because the
Yeah.
downward motion is cancelling out the upward motion. Are you getting me?
Yes.
So this value was for displacement. So we have to be very careful because we don't know if the particle is going to be on a return journey. So it's always safe to see if the particle is going to be on a return journey. Assuming the particle wasn't going to be on a return journey, this answer would have distance. But you know if there is a change in direction, then the distance is not going to be equal to displacement. I think that was the main definition I gave when I started with this one, the displacement.
Mm.
So when the displacement is distance is always greater than or equal to displacement. It's always equal to displacement if they are both moving in the same direction. The direction of motion is not changed, but the moment the direction of motion is changed, displacement is going to be lesser than distance. So you have to take that as a consideration.
Mm.
Yeah, we spent much time. Derek, it's like you're going to continue the the rest. But that's a nice question. You can resolve the question again if you've got issues with that. Then it means that it didn't really go well. The understanding didn't really go well.
Mm.
You get contact me immediately so that we
Mm.
follow up there. Okay.
Mm.
Unfortunately, I've used a lot of time. My time is fast spent. Question 8, you didn't get a chance to solve question 8. Oh, I think question 8, we've even solved that before. Oh, no. Yeah, we solved this one before. Remember, that was what I was using. I
The
started,
connecting.
yeah, to connect.
Mm.
Similar to that. Similar to that.
Mm.
Question 9. Question 9. You can write the year, please. Question 8. There's the year. 2008 in winter 4-3. Question number 7. For 10 marks, 20% of the score. Wow. So just
Okay.
write here in the question number
Mm.
and the variant 4-3. Everything in red, just write it. It's going to guide you.
Mm.
Okay. So the next question, question 9 is from winter, blah, 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 blah.
Okay, I've taken the picture already.
Okay. Then question 16, sorry, question 10. These two questions I have not gotten the year yet. That's why I have not
Okay.
indicated that. So maybe we keep on solving the past questions. Maybe we keep on solving the
Okay.
past questions. Like I said, if you master this one, this will be very easy for you.
Mm,
You can take you can take a picture of this one as well.
mm.
Have you taken the picture already?
Yes.
This one or the previous one?
Okay, I haven't taken for this one, so okay, now I've taken it.
Okay. And this one, yeah. I think this one we've solved this already. This was what I was linking the 5 and 5.
Yes, yes,
This was
yes.
what I
You've
was
done
linking.
this. Yeah.
Okay. So yeah, yeah. Today has been a very, very lengthy class. We'll continue solving the past questions until maybe I see that you are fit to continue. Then you start. The loss of motion actually is not any big deal. You know the inclined plane, right? The forces on the
Yeah.
inclined, mg sine theta, mg cos theta, parallel and perpendicular to the plane, those kind of things.
Yeah.
That's the only thing that would be a little bit tricky. It will all come down to supers again, especially free fall when you're doing connected particles. So if the understanding of the free fall is not so strong, you're going to have issues with the connected particles. So just bear with me. Okay.
Okay.
Okay. So that's all for today's class. We'll meet some other time. Take care.
Okay. Okay. Thank you.